Hey there everyone. Today we are going to see a fundamental groups in group theory. The groups of residual classes modulo n Zn. I'm Vipin Kumar Gupta and you can reach me at the following email. At the end of the video, please like, subscribe and share the video and do comment in your feedbacks. Let's proceed without any further delay. First we need to learn equivalence class in Zn. Let us divide all the integers by 6 and collect all those numbers which give us remainder 0. So we have 0. When we divide 0 by 6, we get the quotient to be 0 and the remainder to be 0. The next number is 6. When you divide 6 by 6, the quotient is 1, the remainder is 0. 12 divided by 6 gives us remainder 0. 18, 24 and so on. We also have the negatives. Negative 6 divided by 6 is going to give us remainder 0. On the same lines, we have negative 12 divided by 6 giving us remainder 0, negative 18, negative 24, negative 30 and so on. The collection of all these numbers is denoted by equivalence class of 0. This is how we write it. On the same lines, we can have all numbers which give remainder 1 when divided by 6, that we are going to call it as the equivalence class of 1, and this is how it looks like. We have 1, 7, 13, 19, 25 and so on, and on the negatives we have negative 5, negative 11, negative 17 and negative 23. The equivalence class of 2 is the set of all numbers giving us remainder 2 when divided by 6. We have equivalence class of 3, equivalence class of 4, equivalence class of 5. The question arises, can we have equivalence class of 6? Evidently, we can say a no, because equivalence class of 6 is same as the equivalence class of 0. Remember that if you take any number and you divide it by 6, you are not going to get the remainder to be 6. You will get the remainder to be 0. Thus, we have only 6 equivalence class when dividing by 6. This is how it is. And this collection is known as the group of residual classes modulo 6, denoted by Z6. We will try to show that Z6 is a group. Before that, we need to define a binary operation on Z6. So that is denoted by plus 6. It is given by A bar plus B bar is equal to A plus B modulo 6. Let us see one example of this. So if I take 4 and 3 from Z6 and try to add them, remember that if you will add 4 and 3 as a number, you are going to get the answer as 7. But since we have to reduce them by modulo 6, 4 plus 3 modulo 6 is going to be 1 modulo 6, because 7 divided by 6 leaves us with remainder 1. Thus we can say that 4 bar plus 3 bar is equal to 1 bar. We have got a binary operation, we got to show that it is a group, so we need to verify the 4 properties of closure, associativity, identity and inverses. Let us first talk about the composition table, since it is a finite group. So the composition table is a matrix arrangement wherein the row headers and the column headers are the elements of Z6, and we are going to operate from the row plus column. So the first entry is going to be 0 plus 0, that's 0. Then the next entry will be 0 plus 1, 1, 0 plus 2, 0 plus 3, 0 plus 4, 0 plus 5. On the same lines, we will have the next row to be filled up by 1 plus 0, 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5 is 6. And 6 when you divide by 6 is going to be 0. So 1 plus 5 is 0. So we on the same lines we have 2 plus 0, 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4 is 6, which is 0, 2 plus 5 is 7, which is 1, and so on. We need to first verify the closure. Observe the 6 by 6 entries which we have got after performing the addition. All the 6 by 6 entries are the elements of Z6. There is no repetition in any of the rows or in any of the columns, and there is no element from outside Z6. Hence, we can say that plus is closed in Z6. The next condition is the existence of identity element. We can see there is one row which is same as the row header, and there is one column which is same as the column header. It is this one. So the row 0 corresponds to the column header. That means that 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, 0 plus 4 is 4, 0 plus 5 is 5. Meaning that if you add by 0 from the left, it doesn't make a difference. On the same lines, we have a column corresponding to the column header. It is this one. So we have that 0 plus 0 is 0, 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3, 4 plus 0 is 4, 5 plus 0 is 5. Again, adding 0 from the right doesn't make a difference. Thus, we can conclude that 0 is the identity element. Moving on towards inverses. So for that, we need to first identify all the 0 elements in the 6 by 6 matrix which we have got. So over here. Next, so what we have is that 0 plus 0 is 0, so we can say that 0 is the inverse of itself. Then we have 1 plus 5 is 0, so we can say that 5 is the inverse of 1, that is 1 raised to negative 1 is 5. And there is a property in group theory which says that if B is inverse of A, then A is inverse of B. So since 5 is inverse of 1, I can say that 1 is inverse of 5. Then we have 2 plus 4 is 0, that means 4 is the inverse of 2, and by the property 2 is the inverse of 4. And lastly we have 3 plus 3 is 0, so we can say that 3 is inverse of itself. Moving towards associativity. For associativity, we'll take 3 elements in Z6, call them as A bar, B bar and C bar. By verification, you can check that A bar added to B bar plus C bar is going to be A bar plus B bar added with C bar. And this is a small little proof for it. We'll try to verify this by an example. Let us take 3, 2 and 5 in Z6. So first we'll add 3 and 2 and then add 5 to the result. So 3 plus 2 is 5 bar and 5 bar plus 5 bar is 10 bar. But since we are in Z6, we divide 10 by 6 and we write down the remainder. So that is going to be 4 bar. Now next let us add 2 and 5 first, and then to it we'll add 3 bar. So 2 plus 5 is 7 and 7 divided by 6 gives us remainder 1. So that is going to be 3 bar plus 1 bar, which again gives us 4 bar. So that verifies your associativity. Since all the 4 conditions of group is satisfied, therefore we can say that Z6 with respect to plus 6 is going to form a group. Note that the order of Z6 is 6. It is also abelian since the matrix in the composition table is symmetric. Thank you very much.